Hi everyone, my name is Eric with BigPanda. BigPanda as a platform provides meaningful help in identifying root cause analysis. This can significantly accelerate remediation during critical moments. In today's monitoring stack, it is complex, fragmented, and noisy. When multiple tools create a flood of alerts, IT teams are left struggling to identify and resolve incidents in a timely manner, resulting in poor uptime and angry customers. With BigPanda's algorithmic alert correlation, alerts from all of your various monitoring tools are automatically unified into high-level incidents, so you can instantly detect critical issues and start taking action. BigPanda's algorithmic alert correlation is just one method of many that can be leveraged in root cause analysis. And in this video, I will be showing you the difference that it can make. So let's switch over to the console and take a closer look. Okay, here we are now in the BigPanda console. Our incident feed is shown here in the middle pane, which provides a consolidated and real-time view of alerts that are automatically correlated together into logical groupings. In this scenario, let's go ahead and purposely turn off the correlation patterns and then simulate and stream in a series of new alerts. This will show what it's like working with alerts individually and without BigPanda's help of first correlating them into incidents. 5 new alerts have just arrived, and out of these, we have 4 different monitoring tools presented. 1 from AppDynamics, 1 from Nagios, 2 from Microsoft SCOM, and 1 from SolarWinds. So how do we proceed in actually remediating what these alerts are signifying? We could look at the details of each alert one by one and investigate the appropriate systems to try and connect the dots manually. As a spoiler, the clue here is that out of the 5 new alerts, some are related to this AppDynamics alert, and some are not. Having to navigate through even 5 alerts to isolate the associations can be challenging and time-consuming. Imagine if the alerts, and ultimately the root cause you're looking for, were all intermingled with not just 5, but hundreds or more. It really would be like trying to find the proverbial needle in the haystack. This is where BigPanda's algorithmic alert correlation comes into the picture and can help determine the links for you. Now, let's turn back on the correlation patterns and check out the difference. When restreaming the same 5 alerts, we can watch as the system determines associations and automatically groups them, instead of ending up with 5 separate alerts like before. We can see right off the bat that 3 of the 5 alerts that came in were automatically correlated into a single incident. If we click into the incident, the AppDynamics and 2 SCOM alerts are shown to have something in common. At the top, these alerts were correlated into the incident under Application Fraud Detector. It is apparent that these alerts are all related to the critical latency error with the fraud detector application picked up by AppDynamics. SCOM found CPU utilization and disk I/O errors on a MySQL host, and thus the critical latency with the fraud detector application can be attributed to the database load issue on the particular MySQL host. The effect is correlated to the cause. This also shows how an application monitoring tool and a system monitoring tool can work in harmony. But the key here is the immediacy at which their alerts can be logically grouped together to give you true, actionable insights. Let's keep the correlation patterns turned on and do another example. We will simulate a small-scale DDoS attack on a regional data center. 17 alerts came in and are correlated together with all of their symptoms easily seen in one place. BigPanda quickly tells you that these alerts have been categorized to exhibit network-related issues. You can verify this because the checks of the individual alerts in the incident are comprised of no pings, network timeouts, and down Ethernet ports. The US West 1 data center is also isolated and immediately presented to you because these alerts all share host parameters that originate from it. With this information collected and presented to you, it enables you to jump in and start fighting the fire, rather than waste precious time trying to sort through everything manually during critical situations. How about we do a third and final example? Let's clean the slate and go into an empty feed instead. We will depict another real-world scenario and show how alerts from virtual machine hosts can be correlated to a single physical host, and how easily BigPanda displays the relevant information. Again, the correlation patterns are left on. We can see from this correlated incident that the monitoring tools Sensu and VROps are correlated. There are 7 affected hosts, and they all occurred within 1 minute. From the titles in the header, BigPanda intuitively categorizes the problem as being disk-related and conveniently isolates this ESXi physical host. Even just by reading the header, it allows us to make a very quick decision about what is going on. A physical machine had a failure. The same physical machine hosted the rest of the virtual machines, which is why we are seeing all of these disk-related alerts. We can see the breakdown by looking further at the list of alerts in the incident. There are the 6 Sensu alerts from the virtual hosts, and then the 1 VROps alert from the physical host. The different check types are here. There is a RAID fault on the physical machine, which resulted in the disk level issues on the virtual machines. That concludes this video and hopefully gives you a look at how BigPanda's algorithmic alert correlation can provide meaningful context for investigation. And it is just one way BigPanda can help you with root cause analysis. Thank you so much for your time today, and if you have any further questions or concerns, feel free to reach us at support@bigpanda.io.